Hello, today we are going to talk about indices. Indices is the plural of index. This is about multiplying the same number. So for example, we know that a squared is equal to a times a. Now suppose we need to multiply maybe a squared by a cubed. So since we know that a squared is a times a, and that a cubed is a times a times a, if you look at this, you'll find that there are 1, 2, 3, 4, 5 a's altogether multiplied. So you know that it should be a to the power of 5. Now, is there a quicker way to do it than to write the whole thing out and count the number of a's? There is, because if you look at a squared and a cubed, we already know that a squared means there are 2 a's and a cubed means there are 3 factors of a's. So rather than writing them out and counting them, all you need is to add up the powers. You see, the powers of 2 and the powers of 3, if you add them up, is 5, which is just the number of factors a when you write them out. And you get 5 when you count them. So the 5 here, you can also get simply by adding up the 2 powers, 2 and 3. So let me write it this way. A squared times a cubed is really the same as a to the power of 2 plus 3. So 2 plus 3 is a new power, which is 5. So this observation gives us a very easy way to multiply 2 powers, any powers. So let's make up something difficult, like a to the power of 27 plus times a to the power of 35. Now that's a very large power. If I have to write out all the factors, that would take a very long blackboard. But I don't have to. I know that I just have to add up the powers. So let's do that. The answer should be a to the power of 27 plus 35. So 27 plus 35 is new power. Alright, let's add those up. 2, 6. A to the power of 62 is the answer, and we can get this quite easily just by adding up the powers. Right? Let's look at division now. Suppose now that I need to divide 2 powers. Let's say I have b to the power of 5 divided by b squared. So I can write this out. That would be b times b times b times b times b, 5 factors of b divided by b times b for b squared. So if I do this, I can easily work that out by cancelling the b's. So let's cancel 1 factor of b from the top and the bottom, and another factor of b, and we have cancelled all the factors at the bottom. So the bottom just becomes 1, and the top has 3 factors of b. So therefore, the answer is b to the power of 3, b cubed. Right? Is there a simpler way to do this? Indeed, there is. Notice that the power of 5 there means that we have 5 factors of b on the top, and the factor of the power of 2, b squared, means that we have 2 factors of b at the bottom. And when we cancel them, because there are 2 factors of b at the bottom, we have cancelled out 2 factors of b at the top. So from the starting 5 factors of b, we have taken away 2 factors of b. Now if you look at the powers, we have the powers of 5 and 2. So what we are saying is, from the power of 5, we need to take away 2 in order to get the power of 3 in the answer. So therefore, b divided to the power of 5 divided by b to the power of 2, we can also find if we simply subtract the powers. So if I take 5 minus 2 as the power, I'll get 3 as the new power, which is correct. So this gives us a new way, a simple way, a quick way to find the answer when we divide 2 powers. Again, without having to write out everything. So let's try something more difficult, like b to the power of 128 minus b to the power of 1 divided by b to the power of 102. That looks really complicated. We have very big powers here, right? But using our new rule that we have learned, all we need is to subtract the powers. We don't have to write out all the factors. That will again need a very long blackboard. So all that we need to do is to take 128 minus 102. 102, and the answer is, right, 128 minus 102 is 16b to the power of 16. So there we have our answer quite quickly. Let's move on. Now, let's look at something slightly more difficult, negative indices. Now, following from the rule that we've just learned, let's look at one example. Suppose that I have to take a square and divide it by a cubed. Now we know how to do this. If we quite simply write out the whole thing, it is a times a for a squared divided by a times a times a for the a cubed. If we write it out this way, the answer is quite straightforward. You cancel the a's, there's an a left at the bottom, and on the top is just 1 over a. That's the answer. Now, what if I try to apply the rule that we learned just now? A squared divided by a cubed. So according to the rule, I should subtract the factors. I should subtract the powers. I should take 2 minus 3 as the new power. 2 minus 3 is minus 1. A power of minus 1. What does that mean? Now that's something new that we have not seen before. And the idea is, because we know that a squared divided by a cubed is really 1 over a, what we could do is to say that the meaning of a to the power of minus 1 is really 1 over a. So this is a meaning that is given to this negative index, this negative power. So in other words, we are going to treat a negative power to mean 1 over the power. Let me write this down. So we are going to say that a to the power of minus 1 means 1 over a. So we have learned a new meaning here. Now, and this new meaning is useful because it allows us to continue to use this rule for dividing powers. We can continue to find our answers by subtracting the powers. So let's carry this a little further by looking at larger and different powers and see what happens. So suppose I have to do b squared divided by b to the power of 5. So now if I use the new rule for subtracting powers, I should get b to the power of 2 minus 5, which is b to the power of minus 3. Now, what does that mean? We have seen just now that the power of minus 1 means 1 over the number. But what does the power of minus 3 mean? Right? So if we do this the long way, 2 squared divided by 2 to the power of 5 is, b squared divided by b to the power of 5 is b times b divided by b times b times b times b times b, 5 factors of b. And the answer is, after we cancel out the b's, from the top we get 1 over 1, 2, 3. We get b squared, b cubed at the bottom. So this means that b to the power of minus 3 really means 1 over b cubed. So that's the meaning of the minus sign. If we see a minus sign in the power, it really means 1 over the power. And in this case, the power here is 3. Alright, so let's now move on to something slightly more complicated. Okay, let's think about a times b bracket to the power of 3. So if we have a product of two factors raised to the power of 3. What does it mean? Let's write this out. So we have AB times AB times AB. Alright, that's what the cube there means. And this is equal to, we have 3 factors of A, that's A cubed. We have 3 factors of B, that's B cubed. So this means that if we have the product raised to the power of 3, that means the cube of the product is the same as the cube of each factor multiplied together, the product of the cubes. So for example, if I have a large power like 100, can I write it out this way? Indeed we can. The answer is each of the factors to the power of 100. So this is also what we'll get if we write out the whole thing in full. And let's look at yet another example. Suppose we have A squared to the power of 3. Can we simplify this? Let's write out in full. This means A squared times A squared times A squared. That's the cube of A squared. Okay. And this would be, if we write each of this out in full, we have 2 factors of A here, 2 of A and 2 of A. So altogether there are 6 factors of A, and we should have A to the power 6. So what I've just done is that I have simply counted the number of factors of A that I have here, and 6 is just the number of factors of A. And instead of counting it this way, I can simply add up the powers of 2. That would also give me the factors of A. Or we can do it even more quickly if we notice that there are 3 powers of 2. So all I need is to do 3 times 2, and I'll also get the 6. And if I'm going to do 3 times 2, I might as well go back to the start where I have A squared to the power 3 and do the 3 times 2 here to get 6. So this observation gives us a quick way to write down the answer. So A squared to the power 3 we can find simply by doing 2 times 3, and that gives A to the power 6. So that's a quick way of finding the answer. Right, let's look at yet another example. Let's look at square root. Square root of A. What does this mean? Square root of A is a number, so square root of A is another number. And the meaning of the square root of A is that if I square this number, meaning that if I take this number and multiply by itself, I should get back A. Alright, in case that looks a little confusing, let's make up an example. Let's say A is 4. So square root of A is 2. Right? So we would expect that 2 times 2 is equal to 4. Which is correct. So what we are saying here is pretty much the same thing. That because 2 is the square root of 4, so if we take 2 times 2, we should get 4. So likewise, if you take the square root of A times the square root of A, we should get back A. So that's what this means. And I can write this as the square root of A to the power of 2 is equal to A. Now it would be convenient if we can use some of the rules that we've learned just now and apply it to here. Now remember one of the rules that we have learned. We have learned that for example, A cubed to the power of 2 is equal to A to the power of 3 times 2, which is A to the power of 6. So if we have a power raised to another power, we can multiply the two powers to simplify the expression. So if the square root of A is defined as A to the power of half, then the square of this will be A to the power of half times 2, which is A to the power of 1, which is just A. So here I've introduced something, well, two new ideas. One is that we can think of the square root of A as just A to the power of half. The other is that we can think of A as the same as A to the power of 1. So these are fractional indices. So half is a fraction and it's an index, so we call it a fractional index. In the same way, we can have A to the power of 1/3, which really means A cube root. And by making use of such fractional indices, we can continue to use all the rules that we have seen just now for multiplying and dividing fractions. And finally, there is a very important index. We have seen indices that are positive numbers. We have seen indices that are negative numbers. We have seen indices that are fractions. we are now going to look at an index that is 0. Can we have a to the power of 0? What does it mean? We can actually find this meaning, discover this meaning, by looking at an example. Let's look at this example. A squared divided by a squared. Now we know what this is. A squared divided by a squared. They are the same numbers. Answer must be 1. But remember that we have learned a rule just now where if I want to divide two powers, I can do it by subtracting the powers. So let's try that. 2 minus 2 should be the new power, and 2 minus 2 is 0. So following this rule, I have just got this as the answer. I've got a to the power of 0. What does a to the power of 0 mean? We know what a to the power of 1 means. We know what a to the power of 2 means. We even know what a to the power of minus 1 means. And even a to the power of half. But what is a to the power of 0? Well, we can discover the meaning by looking at a squared divided by a squared directly, because we already know that it is 1. So this means that a to the power of 0 is equal to 1. So that's the meaning of a to the power of 0. It is just 1. So let me write down these rather special cases. We know that a to the power of 1 is a. We know that a to the power of half is the square root of a. Right? And we know now that a to the power of 0 is 1. And a to the power of minus 1 is 1 over a. So these are the 4 rather special cases in the algebra of powers. Now one thing to note, the square root of a, we already know, we have already seen it, that if you want to take a square root of the number, that number should not be negative. You can't take the square root of a negative number. Alright, because when you take the square root and get another number, then when you multiply that number by itself, you must get back the original number. And you can never get a minus number when you multiply a number by itself. So in this case, we have the rather special, we are in a rather special situation where a must not be negative. So a must be more than or equal to 0. Now a to the power of 0. Let's ask the question, what if? What if a is 0? What is 0 to the power of 0? What this is saying is that if a is equal to 0, it should be equal to 1. Now, since we are talking about algebra, what this means is that it should be true for any numbers of a. For example, if a is 1, then a to the power of 0 is 1. If a is 2, then 2 to the power of 0 is 1. If a is 3, 3 to the power of 0 is 1, and so on and so on. And even if we have minus 1, right? Minus 1 to the power of 0 is 1. Minus 2 to the power of 0 is 1. But what about 0 to the power of 0? can that turn into 1? Can 0 to the power of 0 become 1? Well, let's go back to our initial example where we have a squared divided by a squared to give 1. That's our starting point just now. Now we know that a squared divided by a squared is equal to 1 because a squared and a squared are the same numbers. But now we are going to ask the question, what if a is 0? If a is 0, we have 0 divided by 0. What is 0 divided by 0? There is no answer. It is undefined. So that's the situation that we have here. 0 to the power of 0 is undefined. In other words, a to the power of 0 will always be equal to 1 for any a except 0. So a can't be 0 for this to work. Alright, that means that a to the power of 0 is undefined. We must remember that. Let's look at a to the power of minus 1 now. So a to the power of minus 1 is equal to 1 over a. Again, this means that it should be true for any a. For example, if a is 2, then 2 to the power of minus 1 is 1 over 2. If a is 3, 3 to the power of minus 1 is 1 over 3. It should be true for any a, including negative a's. But again, we are going to ask, what if a is 0? 0 to the power of minus 1 is 1 over 0. What is 1 over 0? Well, once again, it is undefined. So that means that this, you can think of this as a definition or formula. This equation, it is not going to work if a is 0. So we need to remember these as the special conditions if we want to, when we want to use these relations. Alright, let's try out some examples. Let's do b squared times b cubed times b fourth. So the quick way to do this problem would be to simply add up all the powers. So the answer is b to the power 2 plus 3 plus 4. 2 plus 3 plus 4 is 9. So the answer is b to the power of 9. So that's the answer. Alright, let's try another one. Suppose we have 2a squared b cubed to the power of 4. How do we simplify this? Right? So we have 3 factors in here, and the product of this is raised to the power of 4. So the way to do this is to raise each of the factors to the power of 4. So that means we do 2 to the power of 4, we do a squared to the power of 4, and we do b cubed to the power of 4. And then we multiply this. and then we simplify. So 2 to the power of 4 is 16. Times a squared to the power of 4, we need to multiply the powers. 2 times 4. And b cubed to the power of 4, we multiply the powers. 3 times 4. Now we can simplify them. 16 times a to the power of 2 times 4, a to the power of 8. 3 times 4 is 12, so b to the power of 12. Therefore, the answer is 16a, 8b, 12. That's the answer, applying the rules that we have seen just now. Let's have a look at this one. Suppose we have a the cube root of a. What is the fraction? What is the index of this? If you have a cube root, then it is the same as a to the power of 1/3, right? Why is it a to the power 1/3? Well, we know that the cube root of a means that if you multiply by itself, and again, if you do the cube of this, you must get back a itself. So what if we do the cube of a to the power of 1/3? If we apply the rule, we should add the powers. 1/3 plus 1/3 plus 1/3 is 1. We get a as well. So if you compare these two, therefore, we find that a to the power 1/3 really means the cube root of a. So that was correct. We'll stop here now. Thank you.